Hello, I'd like to welcome you to another video from Global Ground Support. Our video today will cover fault code 70. Fault code 70 is probably one of the harder of the fault codes to troubleshoot and diagnose. First off, if you don't know what a fault code 70 is, refer to your heater manual. In the heater manual, you would go to page 72, and this describes what your fault code 70 is. Fault code 70, loss of flame. This code indicates that the CAD cell is open when it should be closed. Loss of flame after the heater has been running. Now, typically what you would look for in a fault code 70 is, let's keep it simple, back to the basics. You need air and fuel, but you need the right amount of air and the right amount of fuel to maintain flame. From your toggle start switch screen, F1 or F3, we're going to press F3. This takes us to the main screen where we have buttons 1, 2, 3, and 4. We'll press button 1. Troubleshooting, component status, more, or escape. We'll go with F3 for more. System history, setup area, password, select, or escape. We'll go to system history. This takes us to fault history, stats, or escape. We'll go with fault history. Now here again, the fault history is a log of your last 5 faults. Now we're going to scroll down. Now remember, we're just looking at a code 70. Even though we don't have any code 70s in here, this is the one that we're troubleshooting. This is what you would look for. So you would look at your codes. Code 70 is in the one that's been captured. You would scroll down. This would give you a list of your codes. You would keep scrolling down. Code 70, loss of flame. Now you would go to the end of your codes and you have fault snapshot. And this is what you want to look at. Fault snapshot is basically a snapshot of the faults of your heater settings at the time the fault occurred. So, fault snapshot, F1. This gives you a description of your snapshot. You will scroll down, keep pressing F1. Fault code. Now imagine that we had a fault code 70. This gives you your fuel pressure actual and your fuel pressure set point. Now, these two numbers should be fairly close to each other. Now, let's say, for example, they're not. Let's say that the actual pressure was 175 and the set point was 250. Now, with that big of a difference in your fuel pressure, that would tell you you would have a problem with the fuel system. A problem could be a bad fuel pump, low fuel pump RPM, dirty filters, low on fuel. Now let's take, for example, if these two numbers were the same. Now if your air pressure and set point, or your fuel pressure actual and your fuel pressure set point are the same, then you can scroll down, look at your fuel signal, air pressure actual, air pressure set point. Now remember, your fuel signal will vary between 0 to 2650. So if your signal is over 2650, then this is another indication that you have a fuel problem. But let's say that it is where in the correct parameters. So next thing we're going to look at is your air pressure. Your air pressure actual and your air pressure set point. If these two numbers are correct, then you know that your air pressure is correct. But if one of them is high and one of them is low, or vice versa, then that tells you that your problem's on the air side. So you would be troubleshooting your blowers, your air pressure transducer, and your blower control head. Now we'll continue to walk you through the screens. Rumble is basically if the heater starts rumbling, if it gets a, instead of a burn, it gets a little bit of an explosion inside the heater. This will create a rumble effect. This is picked up by the air pressure transducer. It will tell you what your high pressure and your low pressure is. So we'll scroll down. Your blower speed. This is your blower stage. And the stages are 1 through 13 are your heating stages. Stage 14 is your light off. Stage 15 and 16 are your post-purge stages. And then your flow rate. This is where you would see what your flow rate is through the heater and your blower signal. Now remember, your blower signal varies between 0 and 4095. 0 signal should give you 300 to 500 RPMs. 4095 signal should give you 5,000 RPMs on your blower. Now, continuing through, you have your inlet temperature and your outlet temperature, stage final and stage actual. Remember, these two stages should chase each other and they should catch each other. And then printout is if you wanted to take a printout of all the parameters, download it to the micro SDS card that's in the computer. This is, you just simply press F1. Now from here our screens are F2 and F4. F2 takes us back up. F4 takes us back to the main screen. Now from here we're going to troubleshoot each of the two areas that we need to look at, our fuel and our blower. Now a couple of things that will help you troubleshoot on the blower side. One is a manometer. The manometer actually measures air pressure. I say air pressure, it's actually inch columns of water in the burn chamber. You would use your manometer, the hoses to connect your manometer. We would connect this up to the air pressure transducer. The other thing that will help you in troubleshooting a blower problem is your photo tach. Here again, this is where you would measure your blower RPM, is with a digital photo tach. To measure the air pressure, we would open the box. In this particular case, we're going to go to the air pressure transducer, which is located inside your heater box. You have your low pressure and your high pressure. We will remove the line off of the high pressure. We would connect our manometer up to our air pressure transducer. Simply hooking up your jumper hoses, feed line from the heater, and then our connection point to our manometer. But basically what you would be looking for at this point is to see if your air pressure transducer is reading the same as your manometer. Keep in mind your manometer is just a testing device. So you would turn it on. Zero it out. And then what you would do is you'd go back into your computer screen from your main menu. Press F4, F3, F4, F1. Troubleshooting component status more. Go back into more. We're going to go to the setup area this time. Press F2. We would enter our password. Proceed, F1, A, F3, S for set, A, set, A, set, A, set. Now from here, we're going to scroll down to blower control test. Blower control test, we would select that. And in blower control test, here you would manually increase your signal. And as you increase your signal, you would see what your reading is on your air pressure transducer. And then you would compare that to the reading on your manometer. Now in a perfect world, they should be reading fairly close. If you continue scrolling up, typically I like to go from the bottom and work my way up, checking about 4 or 5 different points, making sure that the air pressure transducer reads through the complete range, that we don't have a dead spot someplace in the air pressure transducer readings. We would continue increasing our signal. As we would increase our signal, we would see our air pressure go up, and then we would compare that to the reading on the manometer. Another way to do it is escape out. I'm going to have to cheat here, turn the power off, take me back to the main screen. Main screen, troubleshooting component status, more, or escape. Now we're going to go to component status. And here in component status, you can do the same thing. We'll go down to air pressure transducer. Here, we would select it. Here again, it's giving you the reading of your air pressure transducer. You can compare that with your manometer. Now, from here, you could go back to your blower control valve and use your manual override on your blower control valve to spool your blowers up. As you're doing that, you could use your prototac to measure the RPM. Keep in mind that 4095 signal should be 5,000 RPM. Zero signal should be 300 to 500 RPM. Now, I think we've covered the air side about as much as possible. There may be some things that I forgot or we don't need to cover. From here, we're going to look at the fuel side. Now remember, you're looking at the fuel pressure. Going back to the main screen, troubleshooting component status more, we'll go back into more. Setup area, system history, password select. We'll go back to the setup area. We'll enter our password. Again, it's F1 for large case A, F3 for set, F1, F3, F1, F3, F1, F3. Now from here, we're going to do a fuel control test. And we will scroll down to fuel control test. We will select fuel control test. Now remember, as you increase your signal, your fuel pressure should come up. Now at zero signal, you should be around 50 to 75 psi. And this would be recorded right here. So as you increase your signal, your fuel pressure would go up. You would see this on the manual gauge in the fuel manifold. As you get all the way up to 2650, your fuel pressure should be around 300 psi. Now, typically what I see on the fuel side is this particular test is a static test. Several times the fuel pump and fuel system can maintain a static fuel pressure test. If your system checks out okay in a static test, the next thing that you want to do is do an actual heater run or heater burn. What happens in a heater burn, this is actually a flow test. Several times the fuel pump can do a static test, but it fails a flow test. And in that particular case, you would light the heater off, escape out of this here. We'll cheat again, got the power off, repowered it up. When you're doing a heater burn, we look at your fuel pressure set point and your fuel pressure actual. While you're doing that heater burn, those two numbers should maintain or stay very close to each other. Now, here again, make sure you watch your stage final and stage actual. Keep in mind that those two numbers should chase each other and catch each other. If they fail to do that, then it will only go, or the heater will only stage up to the highest stage that it can maintain temperature at. I'd like to thank you for watching the video. Again, my name is Charles Preston. I'm the Service Manager for Global Ground Support. Have a good day. Bye.